Okay, let me give you a little lecture on complex fractions and how to deal with them. This is section 7.5 from the Miller O'Neill Hyde book. Okay, so the first thing to review is right here, how do we multiply and divide fractions? Well, if you have a fraction divided by a fraction, you take the reciprocal of the divisor, which is the second fraction, and that means to flip it, and then you multiply. But as you can see my note here, don't make that 6 over 14 because you're still going to have to simplify because 6 and 14 are even. So instead, this is how we should be thinking of it. 2 divides into 6 3 times, leaving you 1 times 3 on top and 7 on bottom. And here's one with a polynomial, so you can see where we really are doing this, factor and cancel thing. Okay, so you've got this original problem. This is from the homework. I think this was problem number 5. So what we're going to do is take the reciprocal of the divisor, so w minus 3 over w squared minus 16 is the reciprocal, that's w squared minus 16 over w minus 3. And then on the next step here, I just rewrote the problem and then I factored the top. That's a difference of squares. So all the skills you've learned about factoring apply. And then I'm going to cancel the factor w plus 4, leaving me with 3 w minus 4 over w minus 3, and that's the answer. Okay, the most common mistake in this section is to not know when you can and cannot cancel. You can only cancel factors. Factors are things that are multiplied. So here, w plus 4 was a factor because it is multiplied right there by its neighbors. You can't just cancel the w's because they're not factors, but the w plus 4 is a factor. Okay, so let's practice that one more time. Let's look at this one. Okay, so what I'm going to do is I'm going to hit the explain button, and oops, this is how you would do it. Okay, the first step is to take this division problem, write it horizontally, then take the reciprocal of the divisor, that's done on this step right here, and then they factored, so you factored a GCF of 4 out of here, a GCF of 3 out of here. Then 25 is a factor, x to the 5th is a factor, 4 is a factor, and x plus 5 is a factor. On the bottom, 3 is a factor, x plus 5 is a factor, 5 is a factor, and x plus 3 is a factor. So you can cancel any one of those things. You cannot, however, cancel, say, just this x or just this 5, because those are called add-ins, things that are added. They're not factors. So here, 5 goes into 25 5 times, x to the 3rd goes into x to the 5th, x squared times. The x plus 5's cancel, leaving you with 5x squared times this 4, and that's where you got the 20. Okay. So here now, we're going to change strategies. Let's look at number 5. Oh, no, actually we're not changing strategies. That's a very similar problem. So what we're going to do is look at number 6 from the homework. Okay, now this one's going to have an entirely different strategy. And the reason is that we no longer have just a fraction in the numerator and a fraction on the denominator. We now have 5 over 1, 1 over 3y, 7 over 1, plus 1 over 3y. So what we're going to do is look at the explanation given in ALEKS. Okay, these 4 fractions, ALEKS I don't think does a good job of telling you there are 4 fractions here. Actually there's a 1 denominator, a 3y denominator, a 7 over 1, and then another 3y. So what we're doing right here, this is 3y over 3y. That's just the number 1. I'm allowed to multiply by the number 1. Well, then what happens is that 3y distributes, and really this is how I show my written work. 5 times 3y minus 1 over 3y times 3y. And I would write this as 3y over 1, and write it 3y over 1, 3y over 1, just to emphasize that you're multiplying each term by the LCD over 1. Because then what happens is this 3y cancels with this 3y, because remember this should have been written as over 1, and then that's where you just pick up the 1. Then down the denominator, the same thing, you just pick up the 1 there. So the first term multiplies to be 15y. The second one cancels, 3y's cancel, you just get 1. And then etc. So notice the strategy changed significantly. So the first few problems in the homework, number 1 is just a review of integer division of fractions. Then 2, 3, 4, and 5 were the ones where you could flip and multiply. And then 6 on, well, 6 to whatever, 12, these are ones where you need to find the LCD. Okay, so here, 4 fractions, the LCD is x plus 6. Let's look at the explanation. What we're going to do is multiply each term. This is the line of work. That's the way you're going to write the problem on your paper. Multiply the first term by x plus 1. Multiply the second term by x plus 1. I think it's very helpful. That should have been written x plus 1 over, excuse me, x plus 6 over 1. This should have been written x plus 6 over 1 to emphasize that you're going to be able to cancel here, and then what would be left would be 3 over 1. Of course, that's just 3. And then this is a similar problem. But you can go further on this one, because after you canceled and you had 3 there and 9 there, you distributed. See, this is the distributing x. And then you're like, holy smokes, I can keep going. So you factor again, and then you cancel again. And remember, canceling is really division. So you're going to have x plus 3 divided by x plus 3, which is just 1. That's this one that shows up right there, over x plus 3. And there's your answer. Okay, let's talk about one more problem. Oops, we'll just close out of that. Okay, we're going to do, let's just jump down to like maybe number 10 on the homework. Okay, there we go. There are 6 fractions. The denominators are 3, 3x, and 3x squared. 3, 3x, 3x squared. So what we're going to do is the same strategy. We're going to multiply each term by the LCD over 1. Okay, and really, that line of work is right here. 3x squared is the LCD over 1. Again, Alex is being poor. It's not showing you doing that over 1. It times and the 1/3, and then 3x squared times this term, 3x squared times this term. Now they're not showing you the canceling anymore, but that 3 cancels with that 3, and that's where we got the x squared. This 3x cancels with 3, and then one of these x's, leaving you a 7 and an x. That's right there. And then this 3x squared cancels with this 3x squared, of course, leaving you with the 10. On the denominator, the 3's cancel, leaving you with x squared. The 3's cancel, one of the x's cancel, leaving you with 10x. The 3x squared cancel, leaving you with 16. Again, we then factor the bottom, ba-doom, ba-doom, cancel the x plus 2's, and there's our answer. Okay, I hope that's helped a little bit to kind of see the pattern of the problems. You've got ones where you flip and multiply. That's the first few problems on the homework, up to maybe 5. And then you've got these ones where you multiply by the LCD over 1 on each term. Actually, let's take a quick look at the last problem on the homework. This one, you're just going to, it's the same type of problem. You first need to create this complex fraction by rearranging these negative exponents here. Then you're going to have your LCD of a squared b squared, and you can read that here. And then you multiply each term by a squared b squared. That's here, here, and here. And you can see how it all cleans up. Okay, there's construction going on in my building, so I'm going to stop.